In this question, we know the value of cos theta, but we want to determine the value of cos theta over 2. Okay? Well, we start by using the formula cos of 2 theta equals 2 cos squared theta minus 1. This is the process we take when we know the information about a certain angle and we're asked for information about that angle divided by 2. When we do that, we use this specific double angle formula. We use the double angle formula for cos, always for cos, and then we look at whether we're being asked to find sine or cos of theta over 2. If we're asked to find the cos of theta over 2, then we use this version of the formula for cos 2 theta. We use cos 2 theta equals 2 cos squared theta minus 1. Had we been asked for the sine of theta over 2, then we would say cos 2 theta equals 1 minus 2 sine squared theta. Okay, so in a situation like this, always use the cos double angle formula. Always use this one. And then to know the specific one, look at whether you're being asked for the sine or cos of theta over 2. And if you're being asked for the cos of theta over 2, use this version of the double angle formula. All right, now that we know cos of 2 theta equals 2 cos squared theta minus 1, we've learned that something we can do is divide the angle by 2 on both sides of that equation. Okay? So notice the angle on the left was 2 theta, now it's theta. The angle on the right was theta, now it's theta over 2. Now I'm going to go through some steps and try to isolate um, the cos of theta over 2. But the first step I have to do in order to do that is to add 1. So I'm going to say cos of theta plus 1 is equal to 2 cos squared theta over 2. Now, at this point, we might say, well, we actually know what the cos of theta is. It's negative 3 over 4, so let's plug that in. Negative 3 over 4 plus 1 is equal to 2 times cos squared of theta over 2. Well, 1 is the same as 4 over 4. So that's equal to 2 cos squared theta over 2. And negative 3 over 4 plus 4 over 4 is equal to 1 over 4. So 1 over 4 is equal to 2 cos squared theta over 2. And we can divide left side and right side by 2. That serves the purpose of just having cos squared of theta over 2. So now all we have to do is square root both sides. But we have to be careful at this point because we have to know whether the cos of theta over 2 should be positive or negative. Well, we see that the terminal arm of theta is in quadrant 3. But we're not asked to find the cos of theta, we're asked to find the cos of theta over 2. So we need to know where is the terminal arm for theta over 2. So what we're going to do, we're going to take this expression that I'm circling right here, that one right there, and we're going to divide the pi by 2. We're going to divide the theta by 2. And we're going to divide 3 pi over 2 by 2, thereby making it 3 pi over 4. Now, to help you picture this possibly, just remember pi over 2 is equal to 90 degrees, and 3 pi over 4 is equal to 135 degrees. So that means that we are somewhere in the upper half of quadrant 2. We're somewhere around here. Why is that important? Because I want to know whether the cos of that angle should be positive or negative. Well, the cosine of an angle in the second quadrant, i.e. to the left of the origin, will be negative. So that means I can go from here and I can say negative the square root of 1 over 8 will be equal to cos of theta over 2. Okay? So that's like saying negative the square root of 1 over the square root of 8 is equal to the cos of theta over 2. So that's negative 1 over root 8. Now, root 8 is equal to 2 root 2. So what I can do now is I can multiply numerator and denominator by the square root of 2. And so now with a rationalized denominator, I can say that the cosine of theta over 2 is equal to negative root 2 over 4.